Here we go, back with part 2, example 3. Let's say that y equals f of x has a maximum at 3. Circle the best answer for each. We don't know anything about this function, really. All we know, bad diagram, but that's okay, it doesn't matter. We don't know what the scale is here, but we know at 3, x equals 3, it's a maximum. It says the instantaneous rate of change of f at x equals 3 is, well, since it's a maximum, right, the instantaneous rate of change, the slope of the tangent, is 0. Now, if we were going to think about that further, and we are, is then I also know what the instantaneous rate of change is a little bit to the left and a little bit to the right. So if it's a maximum there, I'm given that it's a maximum, then the instantaneous rate of change at 2.9, like really, really close, is going to be close to 0, but still going uphill. It's going to be positive. Similarly, a little bit after, I'm going to have a rate of change that's negative. After the maximum, it's going to be negative. And so, in fact, if I look for an instantaneous rate of change that's positive, 0, then negative, that'll give me that the function is this shape. And we're going to come back to this pattern later in the lesson as well. Note, if y equals f of x has a maximum or minimum, a turning point at x equals a, then the instantaneous rate of change of f at x equals a is equal to 0. That is, the slope of the tangent is 0, which makes complete sense. We saw that up here when, there was a maximum there, the rate of change was 0. And we've seen that a few times. Instantaneous rate of change at a maximum or a minimum is 0. Okay, so what's the next thing? All right, so we've got a function, a profit function, and there may be a typo in here somewhere. Let's see. No, we're okay. It's all good. The profit is in thousands, and the unit price is in dollars, and that's the profit function. Show that the maximum profit occurs when the company charges $15 per unit. Now, one thing you might think about is, well, let's just throw 15 in there and then throw in a bunch of other numbers and see if we can get higher. Well, the thing is about that technique is we'll never know whether we've got the highest or not. So what we could do then is we could think of, well, how do I prove that this function at 15 looks like this? Maximum at 15, positive rate of change at the start, and negative after 15. Well, this is a normal IROC calculation. In fact, we could think of a preceding interval and a following interval and be able to make this conclusion exactly. So this is the technique. So the preceding interval, I'm only going to do a couple of calculations. We promised ourselves we wouldn't be spending too much time doing this. So a preceding interval might be something like, I'm going to do 2 so we can see the pattern. So I'm going to do one that's maybe 0.1 and 0.01. So I'm going to skip to some very good intervals here. So the interval, first of all, would be just 0.1 to the left. Preceding would be 14.9 and 15, right? So then my IROC is f at 15, subtract f at 14.9 over 15, subtract 14.9. And I'm going to fire up I don't have my calculator. I'm going to have to pause so I can fire my calculator up. All right, as promised, there's the calculator. Notice I'm doing this whole darn thing in one step. Negative x squared plus 30x minus 48 minus negative x squared plus 30x minus 48 over 15 minus 4.9 I did in my head is 0.1, and then this answer is going to be the IROC. And see, what's good about doing this then is that I can just go up when I want to do another interval and change the 14.9, say to 14.99. That's what I'm going to do. So that's 0.1, which makes sense, by the way. Preceding interval, we'd expect it to be a small positive number. And when I get even closer, it's going to be even closer. So again, I can go back into this and just change the 14.9 to 14.99, and I bet you it's not going to surprise anybody what this answer is going to be. It's going to be closer to, oops, not W, 9, closer to 0, but still 0.001. Oops, I know why I goofed that up here, because I should be dividing by 0.001, right? Which is going to be 0.0, okay, 0.01. And once you show one calculation, that's dandy. So notice from this calculation alone, I could say it appears that the IROC is approaching 0 as x approaches 15. That's just from that calculation. And then notice that we can do the same calculation from the following interval. Following interval would be values a little bit to the right of x equals 15. And I start from big and go to small, but you know, notice that once we've done a few of these, I'm okay that you skip sort of to the good one right away, the more accurate one right away. From 15 to 15.01 would still have a run of 0.01, and then I do that calculation. Again, I'd have to goof around on my calculator a little bit, but I'm going to assume that you're all right with that now, and that's going to be negative 0.01. So notice what we've got, then this shows this as well, except for what we have is we've got this idea of the IROC. If this is, hang on, move this up a little bit, oops. If this is the numbers x, we've got 15 here, the IROC appears to be 0 there, and it's 0 just because that's what we calculated it to be. It looked like it was getting closer and closer to 0, but for the little bit to the left, the preceding interval, it was positive, right? It was positive, but the following interval was negative. That means it had this shape to the graph, increasing, 0, decreasing. Therefore, x equals 15 is a maximum. Now, I also realize that this is a parabola, and we could have used our grade 10 techniques for that, but this is the story that we're telling for instantaneous rate of change. Okay, so other notes. Basically, I want a copy of this for the minimum too. By the way, put this in green. This shape, this downhill, this frown, this downy, is called concave down. That's the fancy math term for that shape of a graph, concave down. Where if I were going to do, if I had a similar thing, and I had a value, some value A, and I had the IROC was 0 at A, I calculated that, but it was negative and then positive. That means it was decreasing, 0, then increasing. Then I'd have this smile shape. It's an uppy called concave up. And that's what that collection of information shows. This shows also that a x equals a is a minimum. Okay, so let me write that here. X equals a is a minimum turning point. And I've proven that by these calculations. Concave up. Dandy. I think that's it. There's another piece to this lesson that I'm going to put in a third part to this video, and I'm going to allow that to be optional. It's a bit of fun with the calculator, and the calculators are so powerful with this sort of thing, and I do want to show you that, but if you're keen to get on to your review, I suppose you could do that instead. There still is another example to read in the textbook, a whole bunch of homework, and an FAQ for today's stuff too. But there's also the third video that you can try if you get a chance. It'll be a short one where I show you some cool calculator stuff.